Hi, this is Don again, and we're looking at that problem on Chapter 4, Section 2 about the binomial experiment. This is similar to the one that I just showed you using Excel and Ph.D. This one has slightly different values in it. Again, it's the college students who were asked about using credit cards because the rewards program. You randomly select 10 students and ask each to name the reason he or she uses the credit card. Find the probability that the number of college students who say they use credit cards because of the rewards program is exactly 2, more than 2, between 2 and 5, inclusive. Okay, again, reviewing the properties of the binomial experiment so that we can recognize these word problems. We have n independent trials. Here we've got the 10 randomly selected, so that's independent. We've got 2 possible outcomes, success or failure. Here it's yes or no. The reason they use the credit cards is or is not the rewards program. The probability of success is P. In this case, it's the proportion, 21% or 0.21. Probability of failure is Q equal 1 minus P, and the probability is the same for each trial since it's the same group of students, all of which 21% of whom say they use credit cards because of the rewards program. And X is the number of successes that we're interested in. That's 2, and then from 2 to 5 inclusive. Okay, let's look at it. This is the long formula for the binomial. The probability of a value of x is equal to n factorial, n being the number of items in the sample, divided by n minus x factorial times p to the x power times q to the n minus x power. It is a lot and it looks difficult that way, but if you break it down in Excel in a logical manner, it's really not that hard. And here's the way I broke it down. In my color code, blue is input values, yellow are output values, things that are calculated. I put in my n and my p, calculated q, which is 1 minus p, 1 minus n2. My x, initially, the value they're looking for is 2. N minus x calculated is just the m1, which minus 2 gives 8. I calculate n factorial, which is just 10 factorial. And I made a note here that one of the problems you have with doing factorials in Excel is that Excel crashes if you have very large values. I'm thinking it's about 250. Anything above that, Excel tends to crash because the factorial gets very, very large. But in this case, we've got 10, so the factorial of that is pretty straightforward. N minus x, I just took my value there and used the factorial function. I forgot to mention that. Just type equal and type FAC, and you'll be offered up the factorial function. Here, let me just click on that, and you can see that the factorial function is offered, and it tells you need the number that you're interested in, and you just put that in. And then I've got x factorial again, which is just my value of 2 to that factorial again. It gives me a value of 2 because it's just 1 times 2. P to the x, I've got my p up here to the x value, and that's just m2 raised to the m4 value. There's x is 2, so I raise 2p, the 0.21, to the 2 power to gives 0.041. Similarly, I raise q to the n minus x. There's my n minus x value. So it's just m3, which is q, raised to the m5 value to get that value. And then multiplying those together, I get the probability of 2 is equal to m6 divided by m7, that's the n minus 1 factorial times x factorial times p to the x times q to the n minus x, and that gives me a value of 0.301. So you can do it longhand, as I call it, or you can use the built-in binomial distribution function in Excel. And that's got the advantage of my note over here. This formula does not crash for large values of n or x. So it's got that advantage. But it takes as arguments m4, which is the x value, m1, which is n, m2, which is the p. False means we want that specific value. We don't want the cumulative value for these. We just want the specific value for that one x value. And that gives us 0.3011, the same value here. Now to get the last answer, I use the binomial function and solved it for the values of 3, 4, 5 to get these. And then I summed up those three values plus the value for 2 to get the value for the probability of 2 to 5 inclusive of 0.654. So I hope this helps.